How's it going? Welcome back to Freeburg's Free Advice. Wanted to start the year off with something I was working with one of my kids on. We're going to do graphing a hyperbola. So you may not see this. It's kind of like a pre-calc type level, and it's kind of in that conic section idea. And you'll probably actually see hyperbolas more as you get up towards the calculus level. But if you do need to graph them, we're going to take a look at it. So. And I got a cool new toy for Christmas. I'm excited. So I now have a writing tablet, which should give me some better penmanship for you guys today, and I'm pretty pumped up about that. So, all right, let's take a look. So in general, here's our general formula. You're gonna have this idea of x plus a number squared over a number minus, this y plus a number squared. Or it could be the y, portion of this fraction out in front, and that actually will determine what your major vertice is going to be, in which direction this graph is going to kind of open. Is it going to open up and down if the y is the dominant, or is it going to open up left to right if the x is dominant? So let's take a look at this one. So in this case, because the x is the lead, this is going to be our main vertices. So we're going to actually open up kind of to left to right here. I think the most important things for you to find first is to find the center of this hyperbola. So our center here is going to be, there's our x-coordinate. So in this case, and it's always going to be minus the x-coordinate and minus the y-coordinate. So in this case, our center is going to be at 2, comma, and because the y value is plus 3, this will be a negative 3 for our value here. And then what you want to find after that is going to be your vertices and your co-vertices. So the vertice is going to be the major ones. So in this case, our major is the x value. So this here, the 64, whatever the denominator is going to end up being the distance, or the square, basically, the distance from the center to these edges. So in this case, since the square root of 64 is 8, we're going to go 8 units left and right of our center. So since our center is at 2, negative 3, these two vertices are also going to have y values of negative 3, but we're going to go left and right by that 8 units. So if I take 2 plus the 8, we're going to end up with 10. If we do 2 minus the 8, we'll end up with a negative 6. So now I have my two vertices, and then my co-vertices are going to be the y, since the y is our minor this time. And so we're going to have the same x value as the center, and then we're going to go up or down. In this case, square root of 25 is 5. So negative 3 plus 5 gives me a positive 2, and negative 3 minus 5 is going to give us a negative 8. And so now we have those. The other thing that's nice to look for is you want to find the asymptotes. And so the asymptotes are going to be a couple different ways to find it. One, if I were to plot these points, it's actually going to help me kind of build this like box. And so off of the box, you can realistically draw your asymptotes kind of through them from the diagonal to the diagonal. And so what we can find is you can literally just use these as coordinate points and go ahead and find an old school way that you used to with your y equals mx plus b formulas. In that case, you would see that the center is here at the 2, 3. Essentially, I'm going up 5 units and then over 8. So I know that my slope is going to be 5 over 8. And then you have your x plus some unknown y-intercept, right? Well, and then, of course, this is a y equals equation. And so then we can just grab our center and plug in that as a coordinate point and go, my x is 2, my y is negative 3, and then we can solve for b, and we'll see that, yep, in fact, we do end up having 5/8 times 2 plus b equals -3. And so we'll have 10/8, which is 5/4. Plus our b equals, and then again with fractions we're going to want to make sure we have common denominator, so I'm going to convert this into -12/4. So when I subtract 5/4 from both sides, we'll see that b equals -17/4. Okay, so we found here that y equals 5/8 x plus or minus, since it's a -b, minus our 17/4. So that actually gives me the equation of that asymptote. Well, to find the other one, all you would need to do is repeat this process, but our slope is now -5/8. The other way you could actually go find this is you could, actually quite literally, all you need to do is solve. Struggling here with my new pads, sorry. You could actually go ahead and solve for y. So if I take this equation and solve for y, what ends up happening is we, in this case, I like to keep my y positive. So I'm going to add this section over. So we would end up with an x minus 2 squared. Oh, excuse me on that one. That was a mess. All over 64. And then we're going to subtract the 1 over to this side. Equals. And then we've got the y plus 3 squared all over 25. Well, then we can multiply by 25 on both sides. And so we'll see that we've got 25 times x minus 2 squared all over 64 minus 25 equals our y plus 3 quantity squared. And so now we want to square root both sides, and this is going to start to kind of turn into a mess, right? And so, as I'm running out of room, I apologize, I'm going to move it down here. So square root then of both sides is going to, and this whole thing is square rooted right now, is going to be 5 times y minus 2 squared all over 64. And then this minus 25 part, we're going to actually be able to ignore. And the reason for that is that we take off towards the infinities, both towards the positive infinity and the negative infinity. That constant term becomes almost irrelevant to us. And so, fortunately, we can kind of just ignore it in the extremes, which allows us to make this math much simpler, because I screwed that up when we actually took the square root of 64. That should be an 8. And what happens when we take a square root? We end up with the plus and the minus of it. And so now we end up with this plus or minus 5/8 x minus 2. We took the square root, so that's gone. Equals our y plus 3. And so our last step then is going to subtract that 3. So y is going to equal a -3 plus or minus this 5/8 x minus 2. So that's the other way you can actually do it. And then if we double check, multiply that through, we get our 5/8 x. 5/8 times -2 is a -10/8, or again, -5/4. Minus the 3 gets us to the exact same situation. And then if we do the negative, we're in good shape. Okay? So, 2 different ways you can actually go find those asymptotes. But go ahead and use that. So this is the information I think that's important for us to look at. So we're going to kind of skip back and forth between a page here now. and actually graph this. So we know that the center, let's see if I can move forwards here. So we know that the center is now going to be at 2, 3, and I'm going to do these actually by 2's. So this is going to be 2, -3. Okay, so there's our center, 2, -3. Okay, and so that's our center. And then we're going to go plot our two vertices and our covertices. So we need to go left and right 8 and up and down 5. So left and right 8 is going to send us over here, 2, 4, 6, 8, which we had already identified as -6, -3. And then plus 8, so 2, 4, 6, 8. This is going to get us out here at 10, -3. And if we go up and down 5, so up 1, 2, 3, 4, 5, this gets us up here into the +2, +2, and down 5, 1, 2, 3, 4, 5, got us into the world of 2, -8. Okay, so now we've plotted all of those key pieces that we had solved for earlier, and like I said, if we were to connect the dots on this box essentially, we end up, we end up seeing kind of this dotted box, which if we were to connect the corners, we actually kind of get the asymptotes. And so let's go ahead and do that. So if I were to plot the asymptotes here, I can do so by basically clicking and dragging. And so there's one asymptote. And then let's do, let's make those slightly different colors so we're confused. Okay, so there's that guy. And then the other one would go through here. So something kind of like that. And again, these are just the asymptotes. And so as we actually go graph the final function here, we're going to start at our major vertice. And this thing's going to be kind of looking like a parabola that approaches our asymptote on either side of it. And so there, with the black line, is a rough sketch of a hyperbola. Oh, that one got a little bit off. Let's redraw that one. Alright. Let's try that. There we go. Awesome. So there's your hyperbola. Key things to remember. Again, you've got these shifts left and right, and it's always opposite, so go find your center. In this case, it was 2, -3. Then go ahead and find your major vertice, which is always the lead in this case because our x was the first term. Our x is going to be the major vertex there. The co-vertices in this case was the y since it came second after the minus. And then the distance away is always the square root of the bottom. Find the asymptotes either by taking those corners of your box and just solving for it like you probably have since 9th grade in Algebra 1. Or go ahead and actually solve for it, solve for y from the original equation and realize that this constant term will actually disappear as we hit the infinities. Grab all your information, plot it on the graph, and we are good to go, and you got a good looking graph. So thank you for watching Freeburg's Free Advice. Hope you guys had a wonderful winter break. Welcome back to school on Monday. Take care.